Okay, so in this step, we will look at collecting the data, manipulating the data, and feeding the data into the Arduino from the Raspberry Pi. Just to get my head around it, I started an IPython file so I could run and execute the code while I played with it. So I'll just take you through how I started it. Basically using Python 3, and I've got the file named umbrella stand. Right, so first of all we need to import requests. So and I can execute that. Oh, sorry, run that. So now we can do a get request. So we'll type response equals requests.get. And now we'll get the API address, which we registered for in the previous step. So give me a second. Okay, so I'll paste that in there. And then we can run that. And now we'll just print a response. And that's come up with 200, which means it's achieved that. We can also print response content. Okay, that hasn't worked. Sorry. Okay, so spell that wrong. Okay, that's better. And now I can see the content of response. So this has got all the data that we've got from the API, which we saw in its reformatted version on the previous episode when we imported it into a JSON formatter. So to work with this data, we now need to import JSON. Okay. And we can convert it into a JSON by typing data equals response.json. And we can do print. Oh, wrong thing. We can do print data. missing presenters, sorry. So here we have the print data file. In JSON format. We can also look at the data type, and we can go print. We can go print type. And that gives us a class and a dict for it. Okay. And we can finally, we'll just look at what happens if we then print data. Well, not print data, but run data. Here we go. You can see similar to the JSON formatter, we've got all the data we've got presented in this way. And as you can see, we've got, if I scroll down, what's the section we're looking for? Here we go. So we're looking for the hourly forecast. And somewhere in this hourly forecast we'll have, there we go, the precipitation probability. So this is what we're looking for. And this is what we'll set our LED lights to regarding the value here against the time. So there we go. We have the date and time there. So these 2 points are basically what we're looking at, and they'll be what we're setting the lights to in regards to the umbrella stand. Okay, right. Now we need to start manipulating the data, and to do that we're going to import pandas as PD. Okay. Pandas will help us structure our data and kind of analyze our data that we've retrieved. So the first thing we'll do is create a data frame. So if we type d frame equals pd dot data frame data and click run. Oh, there's an error there. Let's see what's going on here. I can see why it doesn't like the word data. Why is that? Oh, okay, yeah. So yeah, let's rerun that. Oh no, doesn't. Oh, okay. I think I know what it is. It's you can see here we've got hourly, and then data's indented, so we need to give it the path of hourly to get this data. Okay, let's run that. Okay, that's better. And D3. And run that. We get our data now presented in a nice frame, and as you can see, we've parsed the data and we're collecting it from the hourly section, and then indented again from the data. So we're getting this section here. Okay, perfect. We also have the ability to list the the columns that we have, well, the column headers, which we can do by clicking list and then dframe dot dot values. Run that. And here you go. Here's in the data section. These are put in alphabetically here. So we've got the time, I've got the temperature, pressure, humidity, dew point, cloud cover. This is it, precipitation probability per hour for 24 hours, which works nicely because we've got a nanopixel ring with 24 LEDs on it. So just to recap quickly, we've got our GET request that we've done. That's got us this data, and then we've converted it into a JSON. And with that information, we've used Pandas, which is a tool to help structure data, to create a table. And in this section here, we've parsed our data so we can look at particular aspects, because obviously we've got loads and loads of it, but we're only interested really in the hourly data, and in particular we're just after kind of the time and the precipitation probability, which is this one here. So now we can create a new data structure. Go df equals dframe. So brackets, open-ended brackets. We can highlight probability, copy that, Control C, Control V to paste that in, and we can look at the time. Just oh, actually, we don't need those in. We can just separate those with a comma. Right, and we will run that. Okay, there seems to be an error here. Let's see. Oh, data frame object is not. Okay, I think we need to. I think I've put these in wrong here. So. Okay, let's run that. Okay, there we go. Dframe. If we run dframe, we'll see what it returns. And yeah, perfect. We've got the precipitation probability, which is very, very low. It's good for London. Got it for a 24-hour time. And here you can see the time. Okay, so in this next section, I'd just like to get a 24-hour forecast. So I want to basically crop this down so I just get from 0 to 23, because my NeoPixel ring's got 24 NeoPixels on it, and to be honest, I think if you take an umbrella out, then you only want to know at maximum the next 24 hours in advance. You don't need to know 2 days in advance what the precipitation is going to be like if you're coming in and out of the door, aren't you? So right, to do that, I will set up another day equals, and we will day equals df.log, and this basically allows you to select a range of data. So what we'll do is go from oh no, wrong ones. We'll go from 0 to 23. You can see here we start at 0, and that would be 23. Oh, and of course we done that all wrong. We need to put C's around those. Okay, let's see if this runs. No, of course not. I can only imagine it's because I've put a comma there. Right, let's try and run that again. Yeah, perfect. So if I now type day in, and I run that, we'll see what it would return, which is 0 to 23, and obviously the previous data we had here. Seems perfect. Okay, now we need to import the to allow us to create some functions for the data we've gotten. This is basically to help assign the LEDs with a color based on the percentage chance of precipitation. So for instance, we want, say, the LED to be red if it's going to rain a lot, and we want it to be green if it's going to be sunshine, or whatever you'd like to set it at. So we import numpty, as that has a series of programs that helps you create functions to do this kind of thing. So we'll do that. We'll run that. And what we'll do first is start creating a color code. This is quite tricky, so I will talk in a bit more detail about it once I've finished. But basically, you want I'm using a statement whereas a probability comes in and it will run through this code and that will assign it a color. And like I said, it's up to you to set your colors and whatever you want to do. So let's start by typing color code. Equals. Sorry. Oops. Okay, so to save a bit of time, I'm going to import this code from the file that I was working on, and we can run it and see how it does. Otherwise, you're probably bored already. Okay, sorry. So if I zoom back in a bit, you can see here we have 4-row in day. So we have our day, we have our table, so we're using that. So we put day, and obviously we're talking about the rows. So we're talking 0 to 23, and here is our variable, so to speak, which is probability, which is if the row is 0.99 or above, then we set it to this color. And then what I've done is kind of that value will work its way down the list to whatever it would fit into, which is say above 0.50, or and if not, it comes down here and it comes this last one, else, and will set itself basically a clear sunny day. There's no probability, which I think is the color green. And then I've just added that variable, which is set up there, to our day column, and let's see if it runs now. And it should be called color code. Okay, color code not defined, so we'll take a look at that. Okay, so okay, I know what it is. So here we've got the capital down there, and we haven't got a capital there, so that should fix it if we run that again. Okay, I don't really understand this, but I've got this a couple of times, this error message, but it seems to have executed what I was asking it to execute. So let's just continue and see how we get on. Okay, so let's type day in, and we can click run. Okay, perfect. So here you go. Now with here we go, the percentage of probability of 0.00. It would give us a green, signaling that it was a clear day. And if we come down a bit, we've got a 0.07 here, and you can see the colours slightly change there. Not really a good 24 hours to demonstrate the difference in color values, but you can see there that one at 0.04 has also changed to a particular value. and there's a slight difference there. Well, there should be a slight difference there in the colour of the wheel as the day progresses. Well, from the current time to 24 hours in advance. Okay, so now I'd like to add the LED address into the table, into the data structure, just so I can see the LED next to its value, its color value that we've given it. So to do this, we can add another column onto our data structure, and to do that, first we'll create the LEDs for each thing. Put that under a variable. So if we type LED equals no, that's not right again. I keep doing that. We can go P0, capital P. This comma P P1, comma, and then so on all the way up to 20. Okay, here we go. Today's in all the way up to 23, and can click run. Okay, that's fine. Now we need to create a column with the LED values in it. So what we can do is day, almost like we've done previously here. We can go LED numbers. Equals LED. And we can then run that. Oh, sorry, done that wrong again. And let's try and run that again. Okay, so if we click day, click day in here and then run again. Yep, there we go. We've added that column, and P0, P1, P2 are associated to an LED on the NeoPixel ring. So basically, the first NeoPixel will be called P0, and it will be given this color value, and so forward. So we've got kind of a nice data structure going on here. Okay, so what we're going to do next is we're going to create one more column, hopefully, and this column is going to be the color code plus the NeoPixel to which the color is associated, and we're going to create a column, and that'll have both the color value and the LED associated with it in the same column. Okay, so to do that, we need to create a column called in day. Same kind of thing as we've done before. Call this code. It's basically going to be the code that our Arduino or Arduino Nano will read in the serial and associate and program what color to change the LED to. Okay, so we'll do that. Go equal call day Trying to remember to put those in capitals this time. Dot map commas string. Plus day what do we call that column again? LED num dot map. Okay, let's run that, see if we've got that okay. Okay, once again it's come up with that error message, but it seems to have worked. If we run the day and see what it returns, yeah, there we go. We've got this column with the associated LED color and obviously the LED that we want to change the color to. So each LED on the NeoPixel ring is addressable, and that is through the form of P23, P14, or whichever one you'd like to address. Okay, so we're basically here now, where we just need to create a code to send through the serial to our Arduino, and the Arduino will read the serial code and change the LEDs on the NeoPixel ring to whatever color they are, based on the percentage chance of precipitation throughout a 24-hour period. So yeah, we're basically there. But what we need to do now is basically just create something that will print this code as a string that we can send through the serial port. So if we first of all compile this first bit of code, which I'll speak to you about in a little later after I've run it. But if we go var equals compiler, put space in there, and then we go dot join day code and click run. Oh, I've got an error here. Code is not defined. Oh yeah, forgot to put those two commas in. Okay, so if we click R, see what that returns. Yeah, see we've got can feed this into the serial. What I have found in this next bit of code is that it's to allow the NeoPixel to change more freely is to put one extra LED on, even though it doesn't exist. It seems to make the LEDs change more freely. Otherwise, it gets to the 23rd LED and kind of stops, and then puts it on right at the end before it stops the code. I don't really know why. I can only presume it's my bad, but I can't really tell you why. I'm not an expert in this field, so sorry about that. So this is how I added this bit of code in. I'll just cut and paste it in because it will make it a lot quicker instead of me typing it out and making an error again. Okay, So here it is here. So I've got string equals another LED. If you see that, then you see that's LED 24, which doesn't exist but kind of does. And then I've got obviously a string 2, which is that var that we've just created there, and I'm creating a serial read, and I'm doing that with string 2 plus string 1. So that's taking our var and then it's adding that string 1 to it. We run that, it should run fine. Yeah, so now if we print serial read, well, if we run serial read, sorry, yeah, as you can see there, you've got that, and to be honest, I haven't put a space in it, so I could go back, put a space there, and yeah, there you go, should be fine. This in this var, this here where we join them together and we've added that in, that creates a space, but you don't need it. You do need it. I'm not really sure, but at least that allows you to look upon what the serial will read a bit easier. The next step is obviously then just to write a bit of code which tells Python where to send this code, and obviously that will be related to where the Arduino is connected to the Pi that we're using to run this Python program once we've compiled the Python program. So I'll add that in now. I'll cut and paste that in, and you can see how it works, and then we'll have a quick review of the whole code put together. Okay, so I've cut and pasted the code that I've written. I've had to import serial and import time, and then if you see here, I've created the Arduino serial, and that equals serial.serial, and this is hopefully where the Arduino can be found. Well, the serial input can be found. I've got a sleep function there just to make sure it sends it all by the time it starts reading it, and then once again after it's read it, just give it a bit of sleep time. So it should be fine. It's not the world's biggest code, so I don't expect there to be any problems. Anyway, that's the code. So if we go to the top, we can have a quick review quickly. So first thing is we're importing requests, and we're requesting data from this API, and then there are several other kind of status requests you can do to look at how your response has been from the GET request, but 200 generally says that it's fine. So then we can print out the response and the content, and you can see we've got masses of data about the weather and all sorts of different things from what we needed. So to start kind of organizing it, we kind of turn it into a sorry, I'm missing where I am now. Yeah, we import JSON, and we kind of turn this data into a JSON, which allows it to be a lot more readable. Vice versa, if you come down, we have a look and printed it so many times, and this one here really helps us to understand what we're looking for. I had a bit of a mistake here that I didn't know that was indented. So we're looking at hourly, and then indented again is data. And that's kind of what we want to get to. So after that, I imported kind of a data structuring code, and that allowed us to delve into the data here. So I've got here the main data we've downloaded, and I've then told it to look in hourly, and then from hourly I've told it to look into data, and then we've created this structure from it, and we've had a look at different aspects here and nailed it down, and then we've started to manipulate the data and create other values from that data, and then combine those things together as we go down to create this kind of serial read code, which will feed into the NeoPixel from the Android. So yeah, I hope you understand that, and I hope you're able to knit it all together and I'll put the files on the Instructable, so you should be able to read. Okay.